Dear students, in today's lecture we are going to discuss about the various types of aprons and the aircraft parking. So far what we have been discussing is about the runways, and then we have discussed about the different types of taxiways, their design features, their utilities, and the types which can be provided depending on the specific purpose or a specific location where they needs to be provided. In continuation of that, in the previous lectures what we have seen is that those taxiways provides access to the apron areas or the aircraft stands where the aircrafts can be parked. So, in that aspect we are going to look at the types of the aprons which can be provided in any of the airport and what may be the different ways in which the aircrafts can be parked. In that sense, in today's lecture is being outlined in the form that we will be discussing about holding aprons, the loading or terminal aprons, the gate positions and the numbers, and the aircraft parkings. So, we will be starting with the holding aprons, and we will discuss that what these holding aprons are and what are the different types which can be there. The holding aprons are generally the places which are adjacent to the ends of runways where the aircraft park briefly before taking off. So, the area which is provided very adjacent to the end of the runway strip where the aircraft is stopping before it takes its position on the runway strip so as to take off, then that particular area or that particular location is termed as holding apron, because the word comes from the word hold, that it is trying to stop, it is trying to just restrict the movement or keeping it at a hold before it finally goes for the operation. Now, there are different ways due to which the aircraft needs to be held at this location where it is very near to the runway strip, and these factors or these reasons may be that the aircraft is already busy with one of the operations like the landing or the takeoff being going on at that point of a time when the aircraft reaches the end of the runway strip, and therefore, it cannot come on the runway. Or there is a engine run up or warming up condition where this is another condition which is related to the heavy type of the fuel which is used by the aircraft. So, before it comes to the runway strip, it tries to just stop before that and runs the engine or makes the engine warm up. So, that takes some seconds, and before doing this one, then after doing this one only this will be coming to the runway strip. Or there is certain checkups which needs to be done in the cockpit, or the instruments on the dashboard or being provided within the cockpit needs to be examined or checked off before any takeoff is being taken off. So, for that reason also the aircraft is stopped just before the runway strip, and that is why this is another reason of holding the aircraft. Now, there can be different shapes which can be provided for these holding aprons, which we look in this figure. Here we can see that this is a rectangular shape being provided. So, we are providing a connectivity between this is the runway strip, this is a wider strip as compared to this strip, this is a taxiway strip. So, these are the parallel taxiways and runways being provided. In the normal condition, at the end of this runway strip, a connectivity is being provided between the taxiway and the runway like this. So, that is the connectivity. Now, at this location where this connectivity is being provided between these two, there is an extra area being shown here like this. So, this is a rectangular area being shown. Any aircraft which is coming from this taxiway, so as to use this runway strip for taking off. So, it will be starting from this direction and will go from this direction and will take off like this. So, before doing this one, this may be required, this aircraft may be required to stop in this area. If there is an emergency, if there is a checkup, then this aircraft will be stopping in this area, whereas if it is in a queue for taking off, then it may be standing somewhere here, so using the taxiway lane strip only. So, this is how this one particular shape is being provided, whereas another shape being provided is a trapezoidal shape, which is shown like this here. So, the aircraft comes this way and takes a turn this way. Here it will be standing in the upright straight portion with respect to the center line of the taxi lane. Sometimes they are also parked in the angled position, and we will be looking at all these different type of aspects as we continue with our discussion in this lecture on holding aprons or the other type of aprons. There is another specific sort of holding apron being provided here, which is provided at the transition phase, where this is the taxiway and this is the runway strip, and this is the transition from the taxiway to runway strip. In this particular location, a widening area is being provided, and this widened area is known as holding apron. Here the aircraft will be standing at this particular location, and it will be clear of this center line, so that if there is another aircraft which is going to use this transition, then that can be used without any interference from the aircraft which is already standing in this bay area. So, in all these cases there cannot be any interference from those aircrafts which are standing on these holding aprons. So, therefore, there are certain guiding principles by which we have to design, or we have to locate, or we have to provide the space for these holding aprons. So, we will look at the design criteria of those holding aprons, and what we observe is that then adequate space needs to be provided for the aircraft, so that they can maneuver easily into the runway strip irrespective of position of adjacent aircraft on the apron. So, that is what I was just trying to tell you in the previous diagram, that if they are standing in this location or this location or at this location, then they should not create an interference for the another aircraft which is moving like this, or which is coming from the runway strip and is going towards the taxiway. So, that interference cannot be there. That is another thing is that there should be sufficient room for an aircraft to bypass parked aircraft on the apron. So, means we needs to provide the clearance sort in between the two aircrafts which are just moving by bypassing each other or just passing from the other aircraft. So, we try to look at the working of this holding apron through this diagram. Here we are providing this exit taxiway, and this is the runway strip. So, this runway strip is going in this direction, and the aircraft is supposed to come from this exit taxiway, takes a turn like this, and then come to this runway strip. And once it takes its position along the center line here, then it will start the engines in such a way that there is a thrust, and the aircraft will start moving, running in this direction. So, therefore, we have the design of this exit taxiway condition as we have discussed in the previous lecture. Now, in this case there is another aircraft which is being placed on the side because of certain reasons, as we have seen previously, maybe like there is a checkup in the cockpit, or there is some problem in the aircraft. So, that due to that reason it needs to be taken away from the movement and away from the operations for some period of time, maybe momentarily or maybe some small time period. So, in that case this aircraft is to be parked in certain fashion. Now, whatever is the way by which the aircraft has been parked, there needs to be sufficient distance between these two aircraft, so that this wing which is taking a turn like this, or if this wing there is which is taking having a curve like this, when it moves from this direction and comes this way, then there remains adequate distance between these two, and this is something like 12 meters clearance being provided between these two aircrafts. Similarly, in this case when we are looking at this movement of this aircraft from this side towards the runway strip, then the inner side of the main gear that should remain at a distance of 6 meters from the edge of the pavement strip, that is, this is the edge of the pavement strip, and this is the way this inner side of the inner main gear is taking a turn. So, that distance is 6 meters, and the same is the condition in the case of this parked aircraft, for which again the distance between the main gear on the outer side and the distance between this edge of the pavement strip should be 6 meters. So, that is the distance being provided here also. Apart from that, there are some marking being shown here. This is the marking being provided for the holding apron, and with this marking we will be discussing, we will take up the visual aids for control of movements on the airport, and there we will be looking at the lightings and the markings. Then in this diagram, the another important thing which is being shown is the distance here that defines the size of this holding apron, and this is around 95 meters to 100 meters, and that depends on the type of the aircraft which is going to use it. In case it is being used by 747-400, then this is 100 meters, where if it is 747-400D, then it is 95 meters. So, it depends on the type of the aircraft which will be going to utilize or use these runways or the airport. On the basis of that, we have to find out the dimensions of these holding bays or aprons. So, this diagram is quite clearly defines how we can provide the holding apron and what should be the size of that holding apron, how it operates. This is another diagram which is trying to depict the similar sort of condition, where there is a holding position of this aircraft which is being held at this location, or there is another position where the aircraft can be held at this location. It depends, means if it is being held at this location, then the aircraft will be taking a turn like this and will be going towards the runway strip in this form. So, specified clearance, as we have seen in previously, it was 12 meters, like similarly in this particular diagram is being shown as 15 meters as a separation between the movement or the turning of this aircraft with respect to this aircraft. And similarly, the size of the taxiway is being shown here as 23 meters and 45 meters for the runway strip, and the taxi holding condition is being defined in terms of the distances which can be there, like here it is 90 meters being defined for this particular holding apron or the type of the aircrafts which will be using is this one. This is another diagram which tries to show the operation of different types of the holding aprons. We have seen the shapes of the holding aprons, the trapezoid sort of holding aprons, or a rectangular or a holding apron which is being provided at the end of the taxiway and the runway strip. So, in these cases, like here it is being shown that this is a runway strip and this is the taxiway. There is a connectivity between this runway strip and the taxiway which is at 90 degrees here. Now, here this aircraft is coming to the extreme location, so that it can start taking off from this location in this direction. Here there are another two aircrafts which has come to this location, and they are waiting for their turn, or there is a problem with these aircraft, so that they are being taken away from the central position which remains along the center line of the pathway being provided. So, they are being parked in this form, so that once they are ready, they can directly start moving towards the runway strip. So, that is the angle at which they have been parked here. Similarly, when we are looking at this trapezoidal form, then these aircrafts which are coming from this taxiway, They are coming to this holding apron and they are taking a turn and will be parked like this. The reason again remains the same, that there should be the minimum type which is being taken from this location for this aircraft to come to the end point of the runway strip, so as to take a takeoff sortie. So, that is the way the aircraft needs to be parked, or they utilize the holding apron location. Here the aircrafts are waiting for their time to come, so that one by one they will be moving ahead, and the other aircrafts will keep coming into the queue like this. So, that is maybe a condition for a very busy airport, where there may be a number of aircrafts which are queuing, and the aircrafts are taking their takeoffs at a time distance of some seconds only. This is another diagram which tries to show that there are still the movements on all the sides of the aircrafts which has been stopped in the holding area, and they are still waiting for their time to come, whereas there are other aircrafts which are moving towards the runway strip, or there is a condition that the aircraft has there is smaller aircraft as being shown here, has come out of its location and it is moving towards the end of the exit taxiway, that is taxiway this side, and coming towards the exit taxiway for the runway strip. So, there is already one bigger aircraft moving towards the end of the runway strip, and it will be taking a takeoff, and at the same time there is another smaller aircraft which is just warming up at this location and trying to and starting to come towards the end of the taxiway. At the same time, there are other aircrafts which are still in waiting, but there is another aircraft which is coming from this direction, and it is moving towards the end of the taxiway and towards the runway strip, and probably is being given priority with respect to the other aircraft. So, in such conditions where this is a normal condition which may happen, then this type of a configuration of a holding apron can be provided. So, that is another way, another type of operation which can be there with respect to any holding apron. So, we have seen various types of operational conditions which can be there with respect to any holding apron, and it depends on which particular type of aircraft is being designed with what capacity which can be handled, or what number of aircrafts can be handled by that airport, and what is the size and what are the numbers of runway strips being provided. Depending on that, this design feature has to be taken into consideration. Now, if we look at the configuration, so what is needed is that the area should be sufficient to accommodate 3 to 4 aircrafts of the largest size expected to be handled by the airport. So, that is one of the important things, that whatever is the size is being defined, that size is defined by the largest aircraft which is coming on the airport, and within that also we take the overall size as equivalent to 3 to 4 aircrafts. Then the entry to the runway strip, this is provided on the basis of the departing aircraft. We should enter the runway at an angle less than 90 degree, and if it is being done in the case of less than 90 degree, then it will permit a rapid turn off from the taxiway. So, that will be more efficient and less time consuming. So, that is the another design feature or specific feature with respect to the connectivity being provided between the holding apron and the runway. Then there should be a facility of bypassing. As we have seen in the diagrams, there are all chances that some of the aircrafts has to be parked, and there will be other aircrafts which will be bypassing them and will be moving towards the runway strip. So, therefore, this type of facility needs to be provided, which means the size of the apron should be large enough, so that if any aircraft is unable to take off, then another aircraft ready to take off can bypass it and can move towards the runway strip. So, in this case, another thing which needs to be provided at some of the conditions is termed as holding bay. and this holding bay is a small area which is located conveniently to hold aircrafts during the busy period until a gate becomes available. So, that is a condition when the aircraft has already landed and it is moving towards the terminal apron, that is where the terminal building is provided, or where there is a gate position up to which the aircraft can go, so that the passengers can come out and can move away. So, that is the gate position. So, in the case of the busy airports, that is a condition may arise that the gate position is not empty, and therefore, no further aircraft can be taken to that location. So, in that condition holding bays are provided. Holding bays are similar to the holding aprons, and they are the small areas where temporarily the aircraft which has landed will be stopped, and as soon as the gate is available, it will move towards that location. The location of these holding aprons or bays, it is defined by the aircraft, and the aircraft should be permitted to enter the runway as close to the end of the runway as possible. That is the thing which we have seen in all of the figures, that the holding bays or the holding aprons were provided at the end of the taxiway and similarly near the end of the runway strip. The reason is that all those aircrafts which are standing in that location, they should reach as early as possible the runway strip, so that they can start their operation, that is they can start taking off. Or similarly, if the aircraft which has landed is to be hold on, then it will be taken away from the runway strip at the end and then can be hold in that location, that is very near to the end of the runway strip. Then holding aircraft should be placed outside the bypass route, so that blast do not affect the bypassing aircraft. And this is one thing which we have seen in the figures, where the different positions of the aircrafts were shown. In all those positions, the one thing which remains is that the location should be such in the way that the blast which is coming out of the aircraft should not create any problem to the another aircraft which is bypassing that holding aircraft. So, the blast should be away from the route through which the another aircraft will be moving. This is what is also being shown here, is that the blast will be coming from this location, that is end of the this aircraft, and if these two aircrafts needs to be placed in the same holding area, then they should be located in such a way that the blast which is coming out of this aircraft is not aimed towards this aircraft, otherwise it will create a problem for this one, or may make this aircraft unfunctional. So, that is how the direction or the angles with which these aircrafts have been parked in this area needs to be varied. And here it is also trying to define that what should be the size of this bay, that is in terms of this distance A, as well as what should be the clearance between these two aircrafts, which is being shown by a value B here. At the same time, it is trying to show the design feature in the sense that this particular slope was being given here is at 30 degrees with respect to the horizontal, which can be provided here, and the distance which is being provided from this point to this location, that is this one, this is 30 meters minimum. Similarly, the other design features which are related to the runway strips or for the radiuses of this is a compound radius being shown here, along with the minimum distance which needs to be provided between these 2 points as 22.5 meters has been shown. So, they are all the design features of any holding apron and are used whenever we design them. Now, in this case where we are talking about all these holding aprons and their design details, we have to look at that what is the number of aircrafts which are going to utilize those holding aprons, and this is obviously going to be governed by the volume of the aircrafts which will be coming to any of the airport. And therefore, we have to look at the peak demand, and this peak demand will be during the peak periods where the traffic volume will be exceeding the holding capacity of the aircrafts. So, that is what I was talking before, is that if there is a busy aircraft and there are all chances that there is a big queue of the aircrafts, and there are takeoffs at some distance of some seconds. So, that is a condition which is happening if the volume is heavy, then and it is exceeding the holding capacity, then it will be resulting in queuing. So, therefore, we require to provide a space where this queue formation can be accommodated. Now, the clearance between the wingtip of the parked aircraft should not be less than 7.5 meters. That is the distance which needs to be there between the wingtips of the two parked aircrafts on the side by side, which we have seen that undesirably in the certain conditions it should be something like 12 meters to 15 meters, but the minimum value remains as 7.5 meters. As far as possible, the entry into the runway should be made with an angle of 30 degrees. That is the optimum angle of turning from the exit taxiway. So, so far what we have discussed is regarding the holding aprons and the holding bays, and specific features related to the holding aprons or holding bays as far as their design is concerned. Now, we will be looking at another type of apron which is known as loading apron, and we will look at the various specific features again in the similar form regarding these loading aprons. Now, the loading aprons are basically the paved areas which are provided adjacent or in front of the terminal building. So, therefore, they are also termed as the terminal aprons, but one specific name which is given is the loading apron, because this is the area where the aircraft will be parked near to the terminal building before it is being loaded, and the passengers will be coming out of the terminal building at this particular location and will be boarding the aircraft. At the same time, if there is a freight or a cargo, then that also will be loaded in the aircraft at this location. So, that is why the name is being given as a loading apron. Generally, it is used for loading, unloading, fueling or minor servicing or checkup of aircraft. So, these are the different operations or functions which can be performed with respect to aircraft in this area or in this location. The airplanes are berthed on the aprons before they are loaded and unloaded, and hence it is also known as parking apron. So, that is another name which is given to these aprons, because whatever airplanes are coming for loading or whatever airplanes are coming for unloading, they will be placed on these aprons before they reach those locations where they can be loaded or unloaded. So, therefore, once they are being parked in that area, so they are also termed as parking aprons. Now, we look at how we are going to decide about the size of any loading apron, and the size of loading apron is going to be governed by certain factors like the number of gate positions, the size of the gates, and the arrangement of gate positions around the terminal building. Before we take another thing, we can just look at what these gate positions are. These gate positions are the locations through which the passengers can reach the aircraft, or those persons or those passengers who are onboarding the aircraft, then they can come out of the aircraft and use this gate position to reach the terminal building. So, that is a connectivity which is provided between the terminal building and the aircraft. So, we have to look at how many gate positions have been provided, and depending on the number of gate positions being provided, and if there is a simultaneous use of those gate positions, then the type of the aircrafts which can use those gate positions at any point of a time is going to define what should be the size of that loading apron. Now, when we talk about this, then the size of the gate becomes the governing factor, and the size of the gate obviously is going to be defined by the size of the aircraft which will be parked at that location for loading or unloading. So, we have to look at the size of the aircraft, we have to look at the way that aircraft has been parked, and we have to look at the clearances which needs to be provided between the two aircrafts being located simultaneously adjacent to each other on the two gate locations which are adjacent again to each other. And another thing is that how the gate positions have been arranged around the terminal building, that is another aspect, and this also will define that how efficiently the gate positions can be operated. And another thing is that if there is a sprawling arrangement which is being used, then it will be increasing the size of the loading apron, so that all those gate positions can be adjusted. Then another factor which is having its effect is the aircraft parking, because as I have just talked is that when you are talking about the size of the gate, then obviously it is going to be the size of the aircraft, but at the same time the way the aircraft is being parked is also going to create its effect. Therefore, not only the type of the parking, but the system in which the aircrafts are parked with respect to the arrangement of the gate positions being provided on the periphery of the terminal building, that is the combination which also creates the effect, which also governs the overall size of any loading apron. So, we start with the number of gates which creates an effect, and how we can find out the number of gates. The gate position is defined as an area which is unmarked for loading off and parking of each type of aircraft, and the number of gate positions to be provided are controlled by peak hour aircraft movements and the gate occupancy time. So, we have to look at these two factors, the peak hour aircraft movements and then what is the occupancy time for each gate. The estimated peak hour volume can be is to be computed, and this is defined as the number of aircrafts which can be handled during the design hour. So, on the basis of the total number of aircrafts which can be handled, we are going to get the number of gate positions which needs to be provided. In the case of a balanced airport design, this volume should not exceed the runway capacity, and that is what we have seen when we have discussed about the acceptance rate and the arrival rate of the aircrafts. The balanced position needs to be achieved. And the design volume, that is the aircrafts per hour, has to be weighted depending upon the ratio of number of arrivals and departures. That is another aspect of design. We have to look at that what is the ratio of arrivals and departures. If it is a balanced condition, then the arrivals and departure are assumed to be equal, and in this case the weighted factor will be 0.5. But if there is a difference that there are more of arrivals and less of departures, then on the basis of that it may be 0.6, or if it is a reverse condition, then it may be 0.4. So, that is how it is defined, and it has its again effect in terms of that how many gate positions will become vacant at any point of a time based on the number of departures with respect to the arrivals, and then what are the requirements, how many gate positions will be required other than the positions which are already under use. Then the gate occupancy time is the amount of time an aircraft occupies a gate, and this is also termed as the ramp time, and it needs to be computed. And this gate occupancy time basically includes the following things depending on the type of operations which will be going on at that location where the aircraft is parked for either the loading or unloading of the aircraft. So, depending on the type of the function for which the aircraft is being parked, we can have different things like how much time it has taken for the parking of the aircraft, that is one thing. Then how much time it is going to take for loading and unloading of the passengers. Then what is the time which is required to be taken for aircraft servicing, which means some emergency checks, the checks for the engines, the checks for the cockpits, etc. Needs to be done. So, how much time it is going to be taken by the mechanical staff or by the electronic staff, so as to check the things, that is another aspect. And then there is a preparation of flight, means before the loading of the passengers for the taking off, the flight needs to be prepared, and in that sense the ACs are made on, so that it becomes cool by the time the passengers are coming inside. Before at the same time, then the various services which needs to be provided through the passengers are loaded in their respective areas. That is another sort of preparation of the flight. Then the crew takes its position at different locations in the aircraft. The pilots take their position in the cockpit, and they also check all the electronic machinery because that is to be checked by them only. So, that is another part of the preparation of the flight. So, there are so many aspects which will take the time, and therefore, before any loading of the passengers is being done, rest of the things needs to be completed. So, before the loading of the passenger is being done, that is the time is being given for this one, there are the three other operations are already over, that is the parking time, the aircraft servicing time, and the preparation of flight. And once the loading is being done, then it takes a very less time so as to come out and make the gate vacant. This gate occupancy time, in that sense, it is going to be dependent further on the type of the aircraft, because it is going to be governed by the size and the characteristics, that is whether the turning is possible or what is the load of the aircraft by which it is to be towed away from the parking area or away from the gate position. So, that is another aspect in this case. So, this is one of the aspect. If the size is very big, it will take some more time so as to clear the gate. The number of enplaning and in-planing passengers, because that is another thing. So, going out or coming in passengers, that needs to be checked in, they are not enplaning, they are enplaning and planing. So, that numbers needs to be also seen. So, how many persons are going out and then how many persons are coming in. At the place where it is a terminal condition, then all of the persons will be coming in or all the persons will be going out. So, how much time it takes is going to be governing the gate occupation time. Then the amount of baggages or the cargo or the freight which is being loaded and which is to be cleared and is to be taken to the terminal building, or otherwise from the terminal building, how much baggage or cargo is to be loaded in the aircraft and how much time it takes to load them, that is another aspect. The magnitude and nature of other services required, the cabin cleaning, the refueling time or some other such features needs to be considered for finding the gate occupation time. Then efficiency of apron personnel, that is the manual behavioral effect. The type of operation, whether it is a through or a turnaround flight, that is another condition. If it is a through flight, then it is going to take a lesser time, but it is a turnaround flight, then it means it when the flight has come, then the passengers will come out of this one, then certain cleaning is to be done, then certain checks have to be done, and then again the passengers will be allowed to come in and the flight will be going back. So, it will be taking more time as compared to a through type of an operation. The another aspect is related which is related to gate occupancy time is that in the case of through flight there is no servicing involved and hence it will be taking something like 20 to 30 minutes. Whereas, in the case of the turnaround time, because the servicing and the maintenance is also involved, therefore, it takes more time, it ranges from 40 to 60 minutes. And the number of gates which are generally provided, a rough estimate is there, wherein the 3 to 5 gates per million annual passengers are provided, means for every million annual passengers 3 to 5 gates locations should be there from where the boarding and unboarding of passengers can be carried out. Now, this value of the number of gate positions can be computed by using this multiplicative equation which is being given here, that is aircraft design volume multiplied with the weighted factor as we have found out, which is computed on the basis of arrivals and departures multiplied with the average occupancy time. So, using these values then we can see that how many number of gate positions needs to be provided. So, this is aircrafts per hour, then this is a weighted factor and this average occupancy time will be in hours. So, therefore, we are left with aircrafts. So, this number of aircrafts is equivalent to the number of gate positions. Now, there are various models which can be used to find out the number of gate positions and some of them are being listed here. There is a Hornzeff model which is used in US, then there is a Piper model being used in Germany, there is Snow and Partners model being used in UK, then there is Lowborough model which is again used in UK, and there is a Hart model which is being used in US. So, number of persons has given their own models on the basis of generally the factors which we have already discussed, which constitute as the design factors of finding out the values. There is another model which is being given by Stafford, and the Stafford has developed this expression for future number of gates, not for the gates which needs to be provided today on the basis of their arrivals and departure rates. What it says is that we can find out this value by n dash minus 2, which is multiplied with the future passenger demand divided by the present passenger demand, and then this value is added with 2. Now, here this n dash, this is existing number of gate positions. So, whatever existing number of gate positions are there, we subtract it, reduce it by 2 and multiply it with the factor, which is factor is a ratio of the passenger demand for future and present, and then we add 2 to that one, which defines that these are the number of gates needs to be provided in any future date. The size of the gate position, now we discuss this, then it depends upon the size and minimum turning radius of the aircraft to be served and the type of the aircraft parking in the gate. So, these are the two things which will be basically governing the size of the aircraft. The turning radius is defined here, is utilized here because the aircraft which has taken a certain position, now as it goes away from the gate position, it will be taking a turn so that it can go to the taxiway. So, therefore, whatever is the minimum turning radius, the separation needs to be there between this turning radius and the turning radius of the another aircraft which is located on the adjacent gate position. So, that is why this will govern that overall size of the gate position. The size of the aircraft generally defines or determines the space which is required for parking as well as for maneuvering, and the extent and the size of the servicing equipments which will be needed for that aircraft. Now, we look at one of the loading apron where the painted guidelines or gate positions have been shown. This is the building line being shown here, and this is the parking angle which this aircraft is taking a turn, and here this aircraft is being placed like this. This is plane parking position, and this is the path of the wing tip, because this is the tip of the wing. So, this is how when it is taking a turn. So, this is the path which will be governed, and the clearance between this path and the building has to be there. So, that this much clearance needs to be provided. Similarly, there is a path of the nose wheel, inbound nose wheel, that is how this nose wheel is going to take a turn. So, this is being shown here. All these markings will be there on the ground. So, this is a diagram which will be there on the ground, and this defines that the aircraft has to come in this way, and then it has to take a position like this for this particular parking area. So, this will be done in the different colors, like this is going to be a yellow strip. So, this is a yellow strip condition, and then there will be other, this is a fainted colored condition which will be provided again on the ground, that is on the pavement. Now, we come to the aircraft parking, because this aircraft parking or the type of the aircraft parking is going to create its effect on the size of the gate position. So, we have different types of aircraft parkings. We have nose in parking, we have angled nose in parking, then the nose out parking, and the angled nose out parking, and parallel parking. So, these are the different types of the parkings which can be utilized for any aircraft. We start with the first type of parking, that is nose in parking. In the case of nose in parking, the aircraft maneuvers into the parking space under its own power and is towed out of position. So, as to go back, it is not possible for the aircraft, because there is no reverse gear condition. So, it will be towed out of the position by a tow. The lower noise lever is there, because there is no use of the power in turning of the aircraft. So, the noise is less. There is a front passenger loading, because the nose is nearer to the terminal building as compared to the tail. So, the front door is used for loading of the passengers. In this case, the smallest gate area is required, because it is coming with the nose in condition. There is no jet blast which is towards the terminal building. So, therefore, there is no deterioration of the terminal building, but there is a problem that we cannot use the rear door, therefore, and it means it will take more time for the loading of the passengers, and large power is required, so that this loaded aircraft can be towed back towards the taxiway. Then there is a angled nose parking. In this case, the aircraft maneuvers into and out of the parking space under its own power. So, that is the similar sort of condition as we have discussed in the nose in parking, but in this case there is a higher noise level because of angle. So, there is a turning associated with it. Again, there will be only front passenger loading, because still the tail will remain at a distance. It will be requiring medium gate area. There is no problem of jet blast, because it is not towards terminal building, it is away from it. But then again the similar sort of problem is there, that is the rear door cannot be used for loading. Another aspect is the nose out parking. In the case of nose out parking, the aircraft maneuvers out of the parking space under its own power. So, it is going out under its own power, but it has to be towed in the this particular location by a tow. Then there is a higher noise level, because the blast will be in this direction, as well as the engine noise will be coming in this direction, and passengers are loaded through the rear door. The front door will not be used in this case, again the gate area required will be smaller as compared to the angled conditions, and the jet blast will be towards terminal building. Therefore, the jet fences or the blast fences needs to be provided on the face of the building, so that it is not deteriorating the terminal building. As being told that we cannot use the front door because the nose is away, and there is a less power required while maneuvering the loaded aircraft out of gate position, because it also uses its own power so as to come out of the parking space. In the case when it is being towed in this parking area, then it is not loaded, and therefore, in that case also the power required for the tow is also lesser. So, we start with another type of, this is angled nose out parking. In this case, the aircraft maneuvers into and out of the parking space under its own power, adds the just similar to the previous case. Then higher noise level is there. There is a rear door passenger loading. The medium gate area is required, and the jet blast again remains towards terminal building. There is a problem of using the front door. The another one is the parallel parking, in which case the aircraft maneuvers into and out of the parking space under its own power. So, that is the advantageous condition. In this case, there will be medium noise level, because the direction of noise will be at 90 degrees. The front and the rear door both can be used for loading of the passengers, but then it requires largest gate area, and there is a problem of jet blast because it will become towards other aircrafts. So, jet fences needs to be provided between the two locations or gate positions of aircrafts, and it requires long loading bridges, because they will be little further away and we require to use two doors. Here we are going to just look at the different types of the parkings which we have just discussed. This is the terminal building, and this is nose in parking, because nose is towards the terminal building. So, we can use the connectivity will be provided like this or like this. So, we can use the front door and the loading will be through front door, and this has come in this location by tow, and it will be also towed back like this, and then it will go to the taxiway. This is the angled condition, this is angled out condition, and this is the parallel condition where we can use both the doors, but then the blast is going towards this aircraft. So, that is the position in this case. Now, we look at some of the aircraft parking systems. There are some systems which are used, they affect the grouping of aircrafts and the simultaneous use of gates, and basically this defines the traffic handling capacity of the overall system. There are different systems like frontal or linear systems, which is also termed as close in, which has the close in parking. There is an easy access in this case, and there is a short walking distance, and but it involves higher cost, because the area will become more as we go in a linear form for the parking of the aircrafts. Then there is an open apron or transporter system, where the longer walking distances are required, and it is a hazardous condition, but it is low cost and there is a flexibility of operations and movements. Then another systems which are there are the pyre or the finger system. This is an economical system where the expansion is easy, but then again it requires longer walking distances. And another system is termed as satellite system, which is where the common facilities are provided, but then there is a high cost, because there is a discomfort associated to the movement of passengers, and it lacks flexibility. So, these are the various systems of aircraft parking, and we will be looking these in combination with the design of the terminal buildings in a later stage in another lecture. So, we stop at this point, and what we have discussed in this particular lecture is regarding the various gate positions, the how we can find out the number of gate positions, the size of the gate positions, and what are the factors which affect them, the aircraft parking systems, etc. So, and the different type of the aprons which can be there, like the holding aprons or the loading aprons. We will be continuing our discussion on airport engineering in the coming lectures. Till then, goodbye and thank you to all of you.